values of random variable. Here you have random variable, then you do the distribution. Examples include normal distribution, binomial distribution, Poisson distribution. These are examples of probability distributions. Mean, median, and mode. This is descriptive statistics. Mean is the average of data set. We all know this. Median is a middle value when data is ordered, and the mode is the most frequency occurring value, number of the highest number of values. Standard deviation and variance. Standard deviation measures the spread or dispersion of data, how data is being spread. That is standard deviation. Variance is the average squared difference from the mean. Average squared difference from the mean. And the standard deviation is the square root of the variance. Square root of the variance. Then correlation and regression. Correlation quantifies the relationship between two variables. It quantifies relationship between two variables, while regression models the relationship, often predicting one variable based on another one. Now, sampling and sampling distribution. Sampling involves selecting a subset of data from a population. When you have a population, you are sampling, you just look and select very few from within, that is sampling. And sampling distribution is a probability distribution of a statistic like the mean from repeated sample. Repeated sample, that's sample distribution. Hypothesis testing. A method to set assumption, a method to test assumptions about the population using sample data. A method to test assumptions about a population using sample data, that is what is called hypothesis testing. And it involves null and alternative hypothesis, p-values, and significance level. This is what it involves in the hypothesis testing. Confidence level. A range of values derived from simple data that likely contains a population parameter and express uncertainty in estimation. Central limit theory. Central limit theory states that the sampling distribution of a sample mean approaches a normal distribution as the sample size increases, regardless of the population or distribution. Outliers and skewness. Outliers are data points significantly different from others. Skewness measures the asymmetry of data distribution. Data visualization. Techniques like histogram, box plot, and scatter plot help in understanding data pattern and distribution. What we have just seen is key, some of, not all, certainly, but some of the key statistical concepts, key definition of statistical concept that you need to know as a software developer or web developer or as a cybersecurity analyst. You need to know this because you need to incorporate them when developing your software or when designing your cloud, when doing your cloud computing. Now we are going to see fundamental theories behind statistical method. What we are doing today is just trying to get an overview, a history of statistics, and how it is related to your field. Probability theory. The core idea of probability theory quantifies uncertainty and randomness. It quantifies uncertainty and randomness. That is probability theory. and what is the application, forms the basis for all inferential statistics, including hypothesis testing, confidence interval, and regression. All these are from probability theory. Key concept: event has probabilities, distribution, e.g., normals and binomial, describe how data behave. This what you need to know. You need to understand what probability theory is all about. Next is sampling theory. Sampling theory, the core idea